All right, so today we're gonna have to do a little bit of chat about what's going on in the community. Then we will have Paul Battison talking about the performance of your Apex code. As usual, we will have some quiz and prizes, and then more chat because this group like to chat. We want to thank our sponsor, BrightGain and Mobile Candy. They're the ones who make us possible to put the videos on YouTube. And in terms of the community news, we have a couple of them. The first one is on the summer release on the 1st of June. It will be available on the production. And June on the 23rd, we are hosting a TDX watch party if you want to watch the TDX with us. And finally, on the partner learning camp is open, which is, please guys, correct me if I'm wrong. This link will link you to a page for, it's like a trailhead for partners to get your skills up, and you also have some certification. And that is pretty much the news for today. Okay, yeah, and now I will give the talk back to Paul Battison, who is the CEO of Cloud Galactico, and he is also a Salesforce MPV and the author of numerous books like Learning Salesforce with Development, which so far is my best. I'm working a lot with it, but you have like other like, oh, I forgot, low code application or low code mastering Apex programming. So you can check it out. And I will put also on the YouTube the link to follow this session if you want to watch it back. So I give back the desktop to you.
Super, thank you. Can you see a presentation screen that is obviously not using the London's Calling theme? Everyone see it?
Yep.
Yeah.
Cool. Super. Yeah, so thank you very much for having me. 1 minute, I'm just going to move something out of the way. There we go. Yeah, thank you very much for having me and for that lovely introduction. Yeah, I'm Paul. I'm the COO at Cloud Galacticos. If you find after this you do want to hear more from me, which would be surprising, at pbattison on Twitter or on LinkedIn, or on GitHub, or anywhere. I'm pretty consistent. A little bit about me. I am the CEO at Cloud Galacticos. We're a UK Salesforce consulting partner. Standard plug, we are hiring. If anyone is interested, please ping me or Mike Gill, who is also lurking. Some of that works for us. He's a very smart man. You can come and work with him. Salesforce MVP, certifications, blah, blah, blah. If you are interested in learning more about Salesforce industries and what that is, the wonderful Anoop that was mentioned a minute ago, we have him speaking next week, I think it is, at the Leeds developer group. So just go into the Trailblazer community and you can find that there. And as was mentioned, I have written a couple of books on Apex and have a course on Apex testing. So tonight we're going to talk about performance and performance in Apex. And we're going to start off by discussing what we mean by performance. We're going to talk about how we measure performance, some choices we can make around performance and some code, and some choices we can make around performance and architecture. And so I've spoken a few times at London's Calling, in fact, and other things on performance. It is a bit of a personal passion area of mine, because it's one of those things that I think that if you're, my background is A, maths, so I like getting numbers and looking at numbers, but also B is kind of, working with a lot of other languages before I got onto Apex. And so when you're working and paying for your own servers and paying for your own resources, you kind of get into this habit of trying to make things run faster and be a bit more cognizant. Whereas I find that for a lot of Salesforce developers, they've not worked necessarily with a platform or a server or language where they're in control of the resources like that. And so are perhaps not thinking about it in the same way. And so it's a bit of a passion project of mine to try and help people think a bit more about it and see how the whole thing fits together. I am going to start by disappointing you all, though, that I will not have a golden bullet or silver bullet, golden solution to solving all of your performance problems. There is no such thing. If anyone tells you they have it, they are selling you snake oil. And if they do actually have it, they are probably Chris Peterson, and he could just turn on what he wants in his own org in the background. So there's no golden answer here. So let's start off by talking about what we mean by performance. And it's important to understand this because when we're going to try and improve something, we should actually know what it is we're talking about first. And as we are all very well aware, too many people talk about things without actually understanding what they're talking about. So the three areas I roughly group things into are background and code performance. So that's stuff that goes on in the background, we don't really see, we're not really aware of, is very low level. We have what I call user perceived performance, which is things that the user cares about, things that they can feel and see and experience in their interactions. And then we have scaling performance. And scaling performance is very much about how we deal with our system growing. If you are working with a company and they tell you that they have bought Salesforce because they plan on getting smaller, then I will be surprised. Most companies want to grow. So that means more users, more people, more customers, more data, and you have to scale with it. And so the first thing I always think about is our kind of standard request lifecycle. And 95%, I think, of people's interactions with Salesforce follow a basic pattern. What happens is you go to a screen, you interact with that screen in some way by pressing a button or clicking something or doing whatever it might be. That then sends a message over the wire up to Salesforce, which is our pretty cloud here in box number 3. Salesforce will then do some processing on that data, be it workflow rules, process builder, flow, Apex, validation rules, all of that sort of stuff. And then eventually it will save it, hopefully, in number 5, or it might retrieve some data in number 5. And then you get a response back down to your browser and you view it. And that's pretty much what most interactions are. You can swap out the screen here to be a phone. You can swap it out to be a tablet. You can even swap it out to be a pair of servers instead. But almost all requests follow that standard pattern. And so when we're thinking about how we deal with performance, we want to think about what areas we can improve our performance in. And I've highlighted all those here with little hourglass icons because that makes things nice and simple. As you can see here, our communication blocks, number 3 and number 4, well, that is one way we can improve performance. We can send less things or send less things less often. So reducing the size of your bundles, reducing the amount of data getting back, reducing the number of calls you're making to the server, that will all increase your performance and is one way of improving things. In box number 4 here, we also have our processing. And so that's things like our Apex code, our workflows, anything that we've got going on when we're manipulating the data before we take some action with it. And then finally, the other area we have is any interactions with the database itself, be that a query to retrieve some data, or be that some DML to save and update some data on the database. Because as we all know, as we can all recite the full save order of execution, making a change against the database invokes a lot of things and can cause a lot of other things to invoke. So we have to think about these things before we can start with defining how we can change the performance of our system in these 3 areas we've looked at. So when it comes to our resource usage, our code performance in the background, this is typically using the minimum amount of stuff. So smallest number of queries, smallest number of, there used to be CPU statements back in the day. Try to remember, I think the limit was 100,000. Keir can probably remember. But now it's CPU time of 10 seconds roughly. Heap size, it's another one that we're looking at. And basically using the most efficient mechanism, which should theoretically make us more performant. Okay, so using less of something and reducing the usage of those resources should theoretically improve our performance. However, I just want to take a quick detour and highlight that governor limits and performance are not one and the same. We're going to use them to help us manage our performance, but governor limits are there to stop us from monopolizing resources. They're not actually there to make us more performant. They are hard limits that we kind of have to avoid hitting. They're, I almost want to say they're like a speed limit. You know, obviously no one ever breaks the speed limit, but what happens is you see 30, you get to 28, 29, and that's it. You're not going over that. And so they're really around avoidance rather than a target. And so it's trying to get 55 queries rather than 90 queries. It's not going to necessarily be our target to avoid that number of 100, but we just need to make sure we're below it. And for most developers, I would guess that if you did 55 queries or you did 90 queries, you're not going to check. You're not going to worry about it. You're not going to know. Most people only realize that they've got a problem when they hit a limit. Performance, on the other hand, is very much an optimization goal. So it's about trying to make sure that things work in the most efficient way that use our resources most effectively. And we'll see later on, this is often a delicate balancing act and not really something we can just answer straight off. The next kind of area of performance I wanted to talk about was user perceived performance. So let's take the CPU time governor limit and the heap size governor limit. Both of those are very much governor limits. They're very much hard limits that we have to ensure we don't hit, but only one of them matters to our end user. Now, I will place money that if I was to sit down with any of you and run 2 bits of code being called via a user interface, and one of them, they were both using exactly the same CPU time up, but one of them was using twice as much heap size as the other, as long as it was under the governor limit, you wouldn't know any difference. Okay, it'd be imperceptible to you. And so what we've got to think about when we are looking at performance is, what is the user perceiving? If you lower the CPU time, they will notice because things will return faster. If you lower the heap size, you know, someone in Salesforce might be happy about you doing that, and you may make sure that you don't hit the governor limit, but you know, there's that perception piece versus the reality of what's going on in the background, and making sure that you are following a UX part versus just a pure technical improvement. So again, it's what the user is going to care about, not necessarily how good we are against the government. And then the final one is scaling performance. So it's how does our application perform as we add more users? So more users are then going to create more records. More records probably need us to have more functionality, and so our processes get more complicated. That means we're going to start adding in triggers. So triggers, process builders, flows, probably some more queries, adding in some sharing rules. All of these things that we start to add on as our system gets more complex and we grow is going to impact our performance. A lot of people don't think about things like sharing when they think of the performance of their system. Those sharing rules will have a massive impact on how much data you can access and therefore how quick your queries are and pieces like that. Okay. So the golden rule I like to follow when working with any of these things is to always think about the user. Focus on what the user cares, not what you're going to care about. If we sat down together and went through that same example I mentioned of, you know, lowering the heap size down, that's wonderful, and we can all sit there and pat each other on the back. But it's only if we could lower the time that it would actually show to the end user that we should care. Okay, so focus on what the user and what the user wants. Now, that user may be a system admin that is getting a governor limit set of errors, and we need to deal with that. But always focus on who your user is for this and how you're trying to fix it. So now we've understood what performance is, let's talk about measuring it. So when it comes to measuring performance, we can just start doing things in different ways and just hope, really. As a story, I once worked with a bank in London where, and this is no word of a lie, where their project manager was telling me that their system wasn't very performant. He was ringing me up and saying, "Paul, the system you built, it's a bit slow for us." And I was like, "All right, what do you mean it's a bit slow?" You know, obviously taking great offense to the idea that I'd have written something slow. And he said to me, "Oh, well, you know, it's taking you a few seconds to come back." I was like, "Well, I'm looking at it here. It's running fine for me." I said, what do you mean slow? And he said, "Well, I'm sat here with a stopwatch. And when I press to start loading the page, I press the stopwatch to start. And when the page comes back for me, I press the stopwatch to stop, and it's too slow. And he sat there in the middle of a bank, in the middle of the city of London, with 15 layers of VPN and firewalls and everything else, and is asking me how I can fix that for him. So when it comes to measurement, we have to be very specific about what we're measuring and how we're doing it. And most importantly, we have to have a methodology to follow. Because if we just start measuring things, we're not actually going to get any value out of it. We need to know what we're measuring, why we're measuring it, and what we're going to do with it. And so I personally like to use the Uder loop. So Uder stands for Observe, Orient, Decide, and Act. It's from the American, I believe it's the military, it might be the Navy, but some part of the American armed forces. And they use this to help them make decisions in battle. Now, whilst Apex is nowhere near as dangerous, perhaps it can cause as much stress as many hostile situations. This is very, very useful for helping you make a plan and stick to it. And more importantly, to communicate with your stakeholders what you're doing and why. So the very first thing you do is you observe. So you sit down, you observe, and you take measurements to see what your system is doing. You then orient to understand what it's actually doing. So taking your measurements is allowing you to say, well, we know that we're using, I don't know, 5 seconds of CPU time in between this start point and this end point. Orienting that, you then look through and go, actually, well, we're noticing that we're using most of that in this loop here. And this loop here is the one that is taking up most of that time. That then leads you on to number 3, which is to make a decision. What are you going to do about it? Are you going to do anything about it? It's a very fair thing to say, I'm not going to do anything and I'm just going to leave it as it is. So have a think about what you want to do and whether you want to take any action. There's many situations that I've been in where I've gone in, I've looked at the performance of the system, and you know what? It's not perfect, but it's a choice between spending another 2 or 3 weeks trying to go through and update it and, you know, kind of make more tweaks, or getting it live for the customer. And I know which one the customer is going to care about. So it's sometimes a decision to just take more measurements as things grow and change. And then the final step is to then act upon that. So either to make the change or to continue taking the measurements. And whichever one you do, you then go back into the cycle. So you observe, see what impact your changes have had, orient around those changes to reassess the landscape, decide, and then act again and again. And this makes it very clear and easy when communicating to stakeholders exactly what you're going to do and how you're going to do it. So when it comes to actual measurements, then we have 3 things we can use in our arsenal to help us. We have governor limits, and we can use them to help us understand how performant we are. We have the limit methods, which are very closely tied to the governor limits, but are a separate piece itself. And then we have my favorite part, which is order analysis, which is where I'm going to need to be reined in before I go into too much detail. So governor limits, they're guidelines. For anyone who's seen the Pirates of the Caribbean movies, they're more guidelines than rules. If you break them, people are going to be very, very upset, and they're there to stop you monopolizing resources, okay? You want to make sure that you stay within the governor limits, you don't breach the limit, because if you do, you're going to have a big problem. The limit exception is there are 2 terrible things you can receive on Salesforce. One of them is a limit exception. If you get a limit exception, then you can't handle it, you can't catch it, you've just got to fix your problem. The other one is a GAC. If you get a GAC, then you need to go and ask someone nicely to tell you what you've done wrong and why. With a limit exception, I will guarantee you that you'll never get a limit exception in development unless you're testing very thoroughly. 99% of limit exceptions happen on go live weekends. It's when you're sat there at 8 o'clock on a Friday night pushing, because obviously everyone pushes to production at the weekend because that's the best time to push, is on a Friday night. And you're doing your data load, you've spent 3 months working on this, everything's been great, users love it, feedback's wonderful. You go to push in all that data and suddenly, bang, limit exception, and yeah, it's not great. You just want to cry. So make sure you are testing against the limits during testing. So run data loads as part of your testing. Don't do a data load without having done a test data load 10 times, okay? And it should be the same size as the main data load. You want to make sure you have it down pat. You want to make sure that you know exactly how it's going to behave and what it's going to do with that volume. Make sure that when you're writing your unit tests, you write your unit tests to work in bulk. You know, think about bulkifying your code properly. One of the there's another book which is Advanced Apex Programming by Dan Appelman. Really good section in that about making sure that all of your methods are written to deal with bulk instances. If you develop with bulk in mind, you'll never have a problem, okay? Or your problems are less likely to occur. So always make sure you're testing against the governor limits, reviewing what's happening, and that you verify your extreme scenarios. As a developer, we want to be looking at doing our own testing as we go, though, as I mentioned. And one of the things we can do there to inspect our code and to really understand what's going on is to use the limits methods. And so if we think about checking the governor limits as just making sure that we're going to be okay when it's a go live weekend or when we have a big data load or whatever it might be, using the limit methods is when we want to peek in under the hood and we want to analyze how the system is working. And so for those who aren't familiar, Salesforce provides a limits class. And the limits class has a number of methods on it that allow you to take measurements on how resources are being used. So it will tell you both the usage at the moment and then the total available limit. And so for something like your CPU time, as you take the measurement, it will increase and the limit obviously stays fixed. With others like heap size, it will fluctuate up and down as you use, and the Salesforce garbage collection system kind of cleans things up. You know, it's a very, very efficient garbage collection tool built upon the JVM. It works very well. The biggest problem we have with the limit classes, though, also the limits class, is it's a bit of a Schrodinger's cat problem. So everyone's heard of Schrodinger's cat, I'm sure, the cat that's locked in a box. There's an isotope that will decay. And at the time, it's got a 50-50 chance of decaying. There's a 50-50 chance the cat is dead or alive in the box. What most people don't get about the rest of that story is that opening the box changes what the state is. So as soon as you open the box, you know whether the cat is dead or alive. And I'm really sorry for Amnon, who was just showing us his brand new cat and talking about his brand new cat to talk about this one. The cat is always alive. The cat's always fine. No cats were hurt in the making of this presentation. But with our limits class, we have that same issue. As soon as we take a measurement, say, for example, our CPU time measurement, well, taking the measurement takes some CPU time. So we've automatically changed what is happening. Now, it's a very, very minor, tiny change. But the point I want to make here is that when we're doing our testing, we have got to admit and accept that that's going to happen, and then make sure that we've gone through and been consistent with it. Okay, so it's okay there being this difference. That's life. That's what all experiments and measurements are about. We want to minimize that, and the best way for us to minimize it is to be consistent. And one of the ways that I find best to do that is to make sure that when I'm doing my testing, I'm using unit tests. So unit tests I can run again and again and again and again and again. Then we can work through and we can check and take averages and measure them properly. You never do just one run and get one value. You do 100 runs and get 100 values and average them out. But we need to be very, very aware of it. Once we've got all of our measurements, then the next thing that we can use is order analysis. And order analysis is where we go from kind of being, plain developers just checking things and looking at some numbers to being a bit more kind of, mathematical and rigorous around what we're trying to do. And so what we're going to do is we're going to extrapolate how our solution is going to scale under load. And so if we follow that practice of writing some Apex unit tests to help us do this in a fast and repeatable manner, it's going to be much more repeatable than clicking through the UI 100 times to do it. What we can do is we can then check to see how our system runs under 1 record, under 5 records, under 100 records, under 1,000 records, under 5,000 records. And we'll run those tests multiple times in order to get multiple results. And once we've got multiple results, we can then start to plot these on a graph and we can start to see how our system scales. And what we're trying to get as the outcome from this is, at what point do we break, and how is our system going to change? This is then going to notice, do we need to do anything? Okay, and so it takes us into the act portion. So I put this graph in here. This actually wasn't in the original London's calling tool. But I've added it in here because I think it adds a bit of color around what is called big O notation and some of the scaling factors. So if you don't like maths, ignore this for the next 2 minutes until we move on to the next slide. But if you're interested in knowing how we want things to scale, this is it. So if we look here, what we can think of is the x-axis along the bottom is the number of records we've got coming in. Okay, so little n is our number of records. Big N on the right is the percentage of our governor limit usage. So very, very simple analogy here. At the very bottom, we have this purple line that means it doesn't matter how many records we have, it's always going to use the exact same number of limits and resources. That's an ideal situation. That's super predictable. We then have the dark blue and what I'm going to call the teal line, which are log n and root n, which have kind of flattenings and asymptotes that are very, very good still. They will grow, but they'll grow to a point and then flatten out. We have our green line here on our diagonal that is n, and that's just saying for every record we add in some fixed portion of resource usage. But then everything to the left of this is where we start to have problems. So when we get into n log n, but particularly when we get into n squared or exponents of n or n factorial, what that means is that for every record we add in, we are then doing a lot more resource usage. So taking an example of n squared, if every record we processed, we would use 2 resources. With it being a scaling factor of n squared means that if we double it, it means we will quadruple the resource usage. Okay, so n squared as an example, double the usage, quadruple, double the records, quadruple the usage. So moving on from that, for those that hopefully are now back with us if they got bored by the maths, we have another graph here, which is actually doing this with some Salesforce data. So I will show you this code later on that produced some of these. And what this does is we've gone through and we've looped over some records, just a very simple loop, just for making this run nice and easily. And I've taken multiple measurements at multiple different numbers. I've averaged them out, and the averages are my blue dots. And what you can see here is that I've written some not great code, because this is a bit of a curve. Okay, don't know if you can tell with the gold line of best fit, but this parabola will then be scaling roughly at an x squared rate. So if I were to double the number of records here from 250 to 500, my resource usage has gone from 2,000 to about 8,000. So I've quadrupled. Okay, so this would be bad code or a bad situation for us to have, because what's going to happen is as our system grows and as we have our users create more and more records, or we have more and more records come into the system, things aren't going to scale properly for us. So obviously we want to talk about some concrete actions we can take, some code choices we can make and their performance impact. But as I mentioned at the start, this is all a bit of a balancing act. Everything is interconnected. All of the resources, everything on your computer is all interwoven together. There's no free lunch. So you can't just say, I'm going to make all of my CPU time really low, and I'm not going to have any impact whatsoever upon my number of queries, my heap size, or anything else like that. That doesn't happen. Okay. So what we've got to do is we've got to appreciate that again and understand that when we're making these decisions, we're finding the best optimization for our code at that time. Okay. That optimization may change in the future, and we're going to be good and we're going to appreciate that and change it. And then similarly, we've also got to understand that what works for me or my code at this point in time might not necessarily work for you and your code at this point in time as well. So the 4 key areas we're going to look at. Loops, I've mentioned them before, but they are where a lot of things can go wrong. We're going to talk about heap size and how the heap size gets utilized. SOQL and how SOQL queries can have an impact, and then the platform cache as well. I'd be very, very interested to know how many people actually use the platform cache. So I don't know if Todd can run a poll or something in the background, if that's possible, to figure out how many people, because we've got 45 people here, how many have now used it. So we're going to look at some different loops. And so what I've done is I'm going to jump over to code, and I'm actually going to bring my code down. And so what we've got here is, I'm going to zoom in a touch, there you go, is I've got a test class that I've written. And this is a test class that is used in the book for anyone that, and it's available on GitHub. If you find my GitHub profile, again, P. Batterson, it'll be in there somewhere. And what we've got is a test setup method that's creating 4,000 accounts. And this is nice and easy for me to configure, and I can change it every different point I want. And then we have different types of loops. So we have the SOQL for loop that I'm sure everyone's familiar with. We have, just for S object, and then our variable, and then we have our query. And all I'm doing in my loops is consistently setting some string to be the value of the account name. And what you can see I'm doing here is I'm recording the CPU time before I do the loop and the CPU time after I do the loop. I'm utilizing my very expensive maths degree to take one away from the other to tell me how much CPU time I've used. Okay. We've then got, I added this one in just out of interest, where we are calling to get the name using dynamic apex rather than just .name, just to see if that has any impact. We have the batched for loop. So I don't know how many people have seen this or used this before. With the batch for loop, you have your iterable variable be a list, and you will then get back lists of 200 records at a time, which you can then loop over. So if you have lots and lots of highly complex objects coming back and records coming back, this is a good way of managing your heap size. Not a lot of people have seen this. It doesn't get featured in a lot of the documentation. I can see a few people shaking their heads. We then got the last two, which are Iterator External Max. So everyone's seen this sort of for loop before. If you've worked with any other language for definite, for integer I equals 0, I is less than j, I plus plus, and you loop over and over again. And what we're doing here is, in this one, we're doing the query and also setting our max counter variable external to our loop. And I also have another one here where we are setting it internally by calling .size every time. And so this is just a set of methods that I've got here that allow me to run and retrieve some data and go through and see what is happening. And so I'm going to run them for you now. It's going to create 4,000 accounts in the background, and we're away. And so if I were testing this bit of code, what I would be doing is running this 4 or 5 times to see what my numbers were, and I'd be changing the value and running it again 4 or 5 times, and so on and so forth, to get a large sample of data. And what you'll tend to find is you're running it, you'll notice they get to a certain set point. Now, it will tell me my tests have failed to run. That's because every test has a system.assert false in there. And the reason it does that is because I want to get out the error message. So we're just using our nice Salesforce assertion methods. All you can see here is I've got some different totals. So our Iterator External Max took 85 milliseconds. Our Iterator Inline Max, so where we're calling .size every time, took slightly longer at 106. Our standard SOQL for loop, so up here, that took 208. If we add dynamic apex in there, it takes slightly longer at 261. And our batch for loop takes 360. So a number of different values we can see there. Now, again, this is one run done live. We would do a number of runs, typically minimum I expect is 5. I probably do 10 normally if I'm doing real performance profiling. But what we can do is we can take those and we can put them into a pretty graph. So here is one I made earlier in true Blue Peter style. And I've only done the inline SOQL, the batch for loop, and the iterator. But what's really noticeable here, I'm sure you can see, is that our iterator example is roughly, let's call it just under a tenth of the size of, or just over a tenth, so maybe a ninth or a tenth of the size of our batched for loop, which is the largest one here. That's a massive change. More importantly is to think about what, this all looks great, it's some numbers, yep, the smaller number is better than the bigger number. But that difference is actually half a second. Now, if you've got another 3 seconds worth of code working away, or if you've got other areas where you could improve this, that half a second can make a big difference. Now, interestingly, the difference here between the iterator and our inline SOCL is about 140 milliseconds, say 100 milliseconds. Is that big a difference? Maybe not, okay? It's possibly perceptible if you're Google and people are searching for something. I think there's a apocryphal tale that if they increase it by 100 milliseconds, they watch it drop by a certain percentage. But for most of our end users, it's not going to be necessarily the bottleneck. But this is what I mean about focusing on what your users are going to notice and care about. How is it going to be perceived by the user? Because if we have a few of these loops and we can knock half a second off of each of them, that's going to feel much more rapid. Now, I imagine some eagle-eyed viewers will have noticed that there was a series of other statements where I was taking the heap size limit in there as well in those tests. Now, this is where I mentioned that there is no free lunch, because that same code, when we compare the heap size, is dramatically different. Our inline and our batched SOCL queries are both using roughly the same heap size, and that's expected because they're doing a similar sort of thing. However, our iterator uses a lot more, quite a significant amount more, to the point where, as you can see, it doesn't really look that great on a graph. Okay, so this is obviously going to make us sit there and go, oh, well, we should probably think about, not doing this our loop this way. Well, yes and no. Who here can tell me or can think about how big the actual governor limit is for the heap size in a standard transaction? Anyone know off the top of their heads? Yep, 6 megabytes. Well done, Amnon and Steve and Arinda and Rajeshika and Raja. Okay, so yeah, 6 megabytes. So this is 200 kilobytes out of 6 megabytes. That's not that close to the limit. We could not worry about that. So at this point, we then have to ask ourselves this question of, is our user going to care more about half a second knocked off, or about 200 kilobytes worth of data, 240 kilobytes worth of data being used in the heap size? Well, most users are going to care about it being half a second faster. And so we've got to think about this balancing act. Now, a lot of people I show these graphs to, and then they say to me, oh, well, what we need to do is go in and we just need to rewrite all of our loops to use that iterator method and everything will be wonderful. And that's why I mentioned to you a minute ago about that batch for loop being really good if you have complex data on the heap size. So if you were retrieving, so remember in this loop here, all we're retrieving is just the name of the account. If we were retrieving complex data, so rich text area, long text area, things like that, where we have lots and lots of data that will be added to the heap, then we need to think about something like a batch for loop, because this will suddenly start eating up the heap size much, much quicker. Okay, so it's a balancing act. Please do not go away and just go around rewriting all your loops for the sake of it. But I originally came up with that, or started looking into that different loop piece when I was writing a presentation for Dreamforce back in, I think it was 2012, 2013, 2014, that sort of time frame. And I gave a presentation, I think it was 2014 Dreamforce, where I built a machine learning system in Apex. So I built a complete neural network running in Apex. And it used a lot of batch Apex, and myself and Jennifer Wire, who was the other person who built it with me and presented with me, spent a lot of time thinking about how we can shave time down, because we were running lots of data through the system, lots and lots of maths, lots of matrices, lots of processing. So we had a look at all these things. When you're doing a batch Apex job on 50 million records, then do you know what? Yeah, have a real think about if you can improve that, because it's going to run overnight and take some time. If you're only getting 10 records back, well, which is the most readable for your developers? Which is the easiest for your developers to understand and work with, and use that as your guiding line. Some ways we can improve our heap size in general, smaller methods. If you have smaller methods, they have scoping. Salesforce is going to take care of that garbage collection for you. So follow some good OO practices. When I first started out as a developer, the senior developer I was working with made me sit down next to him and just went through why his code looked like that. And one of the first things he told me was, you see that it always fits on one screen? And I was like, yeah. And he said, that's because that's all you're going to be able to remember. If you have to scroll up or scroll down, you've forgotten about it. And so try and make methods fit onto a screen. Very simple, but good practice. Similarly, only class scope items that need to be class scoped. Okay, don't go throwing everything into the class that doesn't need it. You can manually remove items from the heap by setting them to null. So in that example we saw with our code a minute ago, we could set our set of records to null. This is especially important if you're working with blob data. Blob data and working with things like content documents. So if you, I did some work a while ago where I was taking some content document records, looping over them, or I was taking document and converting them to content document. And I was looping over them, and I had to do a query in a DML, a DML statement within the for loop, because some of these files were that big that would get me near the heap size. So be aware of that, particularly with blob data and how they scale and how you work with them. Another area we can look at is Sockwall. So Sockwall is going to take up time. There was a slide I saw 8-9 years ago, and they used to, the Salesforce architecture slides where you get those wonderful kind of images where it'll have the 3 layers of the cloud kind of superimposed each other. There's like the Einstein layer and the metadata layer and Lightning platform and the apps on top. There was one many, many years ago where it had on there about Sockwall queries always returning in less than 300 milliseconds. I can remember it, but I can't find anywhere that it actually exists. Pretty sure that picture doesn't exist anywhere anymore. Sockwall is really quite clever and really quite fast for what it is. If you think about what Sockwall is doing, it is taking sorry, I'm just reading Todd's evergreen for the win message in there. It's taking a query that you've written in one language, translating that in real time into a query that is written in SQL for an Oracle database, overlapping that with the necessary permissions and profiles and things like that, and then running that query and returning it. And to do all of that is actually quite a complex thing to do, especially to link all the records together. So anytime you're running a query, all of that has to happen, and it takes time up against the database. Okay, so it will use up your time and use up things going on. So first thing to do, run fewer queries. So things like, if you can get parent and child in one query, do so. If you can make fewer trips to the database, do so. Okay, if you can use a formula field or a cross-object formula field or a workflow field, workflow to stamp something to save you a query, do so. It will make things dramatically easier for you. Okay, lots of developers don't think about using the declarative toolset properly. Okay, formula fields are one of the greatest bits of kit that have ever been written by Salesforce. Learn how to use it, and you'll save yourselves a ton of time. If you're going to be using things multiple times, cache the results, hold them in memory and work on them. And then the other thing to do is to improve your selectivity. Okay, so use indexed filters. Okay, make sure your filters are selective. Implement strict sharing. When you implement sharing rules that are proper, they will go away and limit the records that you can find and see, and it will speed things up. Add on limits. Okay, if you add on limits, then you'll make sure that you are only retrieving the number of records you need. Okay? The very, very least that a query should have is a limit. Okay? It should always have a very good selective filter and some where clauses in there, but the worst query you could write is one that only has a limit. Okay? Anything that has no where clause or no limits doesn't deserve to be written. If you follow those practices, it will make things a lot better for you. One of the other things I recommend is to get comfy with the query plan tool. I don't know how many people have used the query plan tool in the developer console. You can effectively enable it. It gives you a little button that allows you to run the query plan and tells you the cardinality and which operation it's running, which fields are being used for indexing, and everything else. Very, very cool. And so the final one, I don't know if Tom managed a poll or not, but is platform cache. So platform cache, I think, has been around now for about 2 years, but I may be wrong on that. It is a temporary data store for frequently accessed but seldom written data. Okay. There are 2 ways you can use it. You can either have an org-wide platform cache or a session platform cache. A org-wide platform cache is one that persists across the entire org and that any user can access. And a session one is tied to your user session, so when they log out, it goes away. Okay. Use it when you have data that is read often and written infrequently. Okay, so think here of things like FX rates and things like that. Or if you have asynchronous jumps. So I was working in a system recently where they were connected, there was effectively a loop to an external system. And so what would happen is we would tell the external system to do something, a user would interact with the community, it would tell an external system to do something, that external system would whir away, and then it would update a record in Salesforce that would then be viewed by the community user. There was a time delay for that to happen, and what that action had done impacted what the user was meant to be seeing. And so the way we can work around that is to use the session platform cache to have overridden values in there. So we retrieve them from the cache first, and that allows us to view them. Okay. As I mentioned, exchange rates are a great example if you are working in a situation where you need more real-time exchange rate data. Other than the standard, Salesforce multi-currency option where you have to set them yourself every so often. And so, final thing, architecture choices and performance around architecture choices. So 3 big areas to focus on when you're thinking about architecture and performance. Number 1 is clicks versus code, that never-ending battle that is the Salesforce equivalent of Vi versus Emacs, is clicks versus code. You should also think about synchronous versus asynchronous and how you structure your processes. And most importantly, as an architect, think about an ongoing review. It's not one and done. It's how you keep on going. So when it comes to clicks versus code, it is neither clicks or code, but making them both work in tandem for success. Okay. I've been working with Salesforce for a long time, as some of those stories and things that Kira and I were chatting about at the start shows. And there wasn't anywhere near the level of functionality for declarative use as there was when I started, as there is now when I started. So, you had S controls if you really wanted to do that. You had Visual Force, you had workflow rules, and that was about it. Everything needed to be code. Now you've got a lot of extra options. You need to learn how to use them both effectively together for scale. Okay? The tough part is to know where the boundary between them is and know how to communicate both across that boundary and how to work to move that boundary. Okay? In most orgs that get to a sufficient complexity, my personal opinion, this is only mine, is that you will see people need to migrate from more process builder and flow into more code. And that's just to kind of keep things in a neater bundle in one area. You can try and keep more things in flow and process builder, but eventually you're going to hit a problem that only can be solved with code. And in an aim to keep things simple on the platform, in an aim to have simplicity within your system, the fewer things you have firing that can overlap, the better. That's not to say that you have to choose one or the other, it's just to know what that migration path is. So when should we move something to code? Okay? When does it get sufficiently complex that it needs to become part of our code base? And how do we manage that transition, and how do we manage that? Okay. Again, it is not one way or the other. It is just how we do it as we get to a large scale. And finally, follow the best practices. There are best practices around flow, around process builder, around workflow, around formulas, around roll-up summaries. I include formulas and roll-up summaries in this because they're wonderful declarative features. They have saved me writing thousands of lines of code over my life. So know what the best practices are, how to use them, and how these all overlap to make the best success. When it comes to synchronous versus asynchronous, first key question, does this need to be done now? When I'm interacting with my system, does what I'm doing need to be done right now? Often when you're sat with a business user, they'll sit there and say, oh, everything needs to happen right away. And you'll be like, well, does it really? Is this going to be straight? I'm working with one client at the moment where an opportunity is closed and they want to create all of these, create a bunch of stuff for field service, basically. And that's wonderful. But as I pointed out to them, it's not like what's going to happen is you close the opportunity and then the installation guy turns up at your door half an hour later. What's going to be better is you want to have that created in its own transaction, potentially. It will allow you to separate things off. It'll make it quicker for the sales user to get a response, and it'll allow you to architect your system in a more efficient manner. Think about what else hangs off the event, okay? So I'm using the word event here, obviously slightly pointed, but think about what events you have occurring in your system. Salesforce can be a very event-driven system if you think about how you want to architect things. It's not necessarily saying it's the best way of doing things. It's saying as you get to a larger scale, you might want to start thinking in that manner to segregate things out. And understand your options for asynchronous processing. Future methods, schedule methods, batch methods, queuable methods, web services, platform events. Salesforce has a very, very rich kind of set of asynchronous options. Yep, change data capture, as I mentioned there. There's loads of very good ones that you can use. Understand how to use them, understand how they work properly, and where you should apply them. Okay. And then finally, ongoing review. Always keep measuring, always keep tweaking. Okay, it should be part of your release cadence, especially on a larger enterprise build, to allow you to add improvements into the next release's work. Today's solution is tomorrow's problem. If you think you've written some code that will last forever, I have news for you. I have written code probably within the past month that I would already be embarrassed about and already know needs changing, reviewing, and redoing. That is the nature of the beast. Okay, everyone needs to be aware of that. So, systems need to change. System needs to adapt. Remember that perfect is the enemy of good. If you're a consultant, you've got to be paid to get things done. You want to follow best practices and make sure it scales and works. But sitting there and getting the perfect system, you will be there forever. You will never achieve. Oh, we've got a poll that's just popped up. 1 second. I'll let that go along in the background. The other thing is keep an eye on the release notes. So new features, they'll help you scale and help you grow. I don't think I've seen yet Salesforce lower a governor limit or add in a feature that has reduced scalability too much. So, keep an eye on the release notes. They're there to help you. And don't be afraid to rework something. Again, that's the best thing you can do. Do you know what? It's a great feeling if you get to delete some code and rework it, or get to delete a flow or a process builder and rework it. That's wonderful. And so the last thing I want to share is this is a quote that I have in the book. So this bit of this stuff has come from my second book, Mastering Apex Programming. There's a section at the end all around performance management and things like that. But there's a very famous computer scientist and mathematician called Donald Knuth, who wrote a really good set of books called The Art of Computer Programming. And in there, there's a very often misquoted quote, which is premature optimization is the root of all evil. That's what gets said 99% of the time. I want to share the real quote, the full contextual quote, because it's really, really important. 97% of the time, you're not going to be able to make a significant enough efficiency that's going to matter. You should still make sure that you know what your system is doing, because that's going to allow you to make sure that you can act on those 3% of situations that are going to make the difference to your system. And obviously there's the required XKCD there on the left as well, all around using a flowchart to prematurely optimize. So yeah, thank you very much for having me. I hope you found this useful and enjoyable. And yeah, happy to take any questions if anyone has any. And I can see that 2/3 of us have never used platform cache in the real world. So there you go. It is a fantastic tool. I do have a bit of code, in fact, I can show on this. I can't run it as a test because my platform cache trial expired in my org earlier on. But what I've got here is a couple of unit tests. Sorry, I know I said I just finished and I'm now whittering on with more code, but I've got a very, very basic FX rate retriever here. And so this is the most mocked up service ever that is going to return a random number for a pairing of currencies. So GBP, USD, for example. And I've written a couple of unit tests. And what this unit test is doing is going away and it is going to get the current rate from my rate retriever. And this one is going to cache it. And then I'm going to just check that I can get it back. And the same here, where I'm getting the particular partition. And in this one, I'm passing in this FX cache class to work with it. So for a cache, you can use it, I'm going to say pretty much like a map. You define some sort of address, so local dot, and then the cache partition name, and then whatever you want to put in there. So pairing, so here, if this was GBP, and say a GBP USD and 1.2, it would go into local.fxrate.gbp USD. The rate would be 1.2, and I'm telling it to live for 900 seconds. And then I can retrieve it from that same cache by going get and then passing in the key. So it really is like a map. You can also pass in this cache.cache builder implementation. And what that will do is that has a single method that is do load. And on that do load, what it will do is it will call our retrieval rate. And so that's really, really useful to allow us to go in and have something that can cache. And then it will go in and make sure that if there isn't something there, it'll retrieve it and return it. Are you asking for the max duration of the cache? I think, I don't know if there is a, what was the max duration? Is it 48 hours or is it longer? I'm going to have to Google that in the background in a minute. But you can set it as you go. So if you can see here, I set it to 900 seconds. It's one of the parameters. But that's using the cache. As I say, I would run the test, but it will fail because my devil trial ran out. And so with that, I will shut up and hand over for questions, if anyone has any.
Cool, brilliant. Thank you, Paul. Thank you ever so much. Yeah, I love those London's Calling slides. We'll have to talk about London's Calling a bit later, then, I guess.
I mean, Francis, Kerry, and Amanda and Louise did a great job.
You funny guy. Right, cool. Yes. Has anyone got any questions for Paul here? Let's take some questions. Feel free to just type them in the chat if you don't want to share your video or audio, or yeah, or unmute yourselves and ask away. And while they're doing that, there was something did come up about some of the tooling you can use, kind of, I guess, during coding time. So that the PMD tools, there is PMD for VS Code, which is handy. That will flag things up as you're coding through to warn you about certain bits. There are some others mentioned. I lost those in the chat and I can't find them. I don't know who posted that. They want to share.
Earset has got PMD built in as part of the sort of pre-deployment checks. Codescanner.io, I think it is. I think has some Apex.
That's right.
There's a Salesforce there's a Salesforce CLI plugin which includes PMD and ESLint.
Yeah.
Yeah.
That's pretty good.
Yeah, I mean that's you're right on top of that, aren't you? Whilst you're writing the code, it'll flag up, which is good. I think Clayton is another one.
Clayton, yeah.
I think it's still about Get Clayton, I think is the website.
Yep, still going.
Yeah. Cool. So does anyone have any questions with Paul other than can you come by and give me a couple of hours of your time to get me past these
Yeah, Paul, you said that your platform cache trial is expiring. Is that a paid extra, or is that just because you've got a dev org, or what's the situation with that?
You get a certain amount in any enterprise org and above. It's in there. Yeah, I'm in a developer org, so all the so I've just posted a link to the code samples in the chat if you want it in there. They are branched in chapter order, but it's, I think, the final chapter. And yeah, what you can do is you can grab those in and stick them in there. The dev org has a 90-day limit. I have another 87 days apparently to wait. No, 84 days now. Something should go out. I was giving a very similar presentation the other day and then discovered that my platform cache partition had expired, which was brilliant as I was demoing it. Partitioning the cache. So you get a certain amount of size that the cache has available to it. Partitioning it says that you're limiting the amount of space that anything can use. So you can so you know when I had the FX rate partition, I could have one which was FX rate, I could have one which was user info, one which was something else, yeah, whatever I wanted. And it would have a limit on the size. And then my understanding is that the oldest stuff gets shoved out as you go. So
would there be a good use case for using the platform cache for things like small amounts of custom metadata, just so that you've kind of already got it available? Because custom metadata is kind of that stuff that doesn't change that often kind of thing. But you've still got to SQL it out to be able to use it. So where do the kind of lines sit between those two?
My 2 cents here, and so again, all of this presentation is Paul's opinion. So, you know, feel free to argue and always do your own research and always argue your side of the case. My view is custom metadata, retrieve it using a SQL query because it'll be that quick. The platform cache is really for kind of unstructured non-Salesforce data you want to have hanging around.
Okay.
So things that the reason I use the FX rate one or that example from kind of that async loop is neither of those were bits of data that existed in Salesforce. You know, so you want them stored somewhere, but you don't really want them creating records.
Yeah.
Any other questions?
So sorry, the iterator loop that you had.
Yeah.
If you do that over a list rather than I++ iterator, what's the speed change there?
So that is the exact use case. So that's the same as the SQL for loop, effectively.
And did it run at the same speed if you query it out before?
I don't know if I've tested that exact example, but my guess is it should run at exactly the same. Well, it depends on where I suppose you put your limit.get CPU time. But my theory would be it would run at exactly the same time. Please go away and test it. I did. When I initially looked into this, I released a couple of videos on YouTube, and if you go into cloudbytes.tv, they're on there as well. And yeah, in there I did a bunch of scenarios. I can't remember if there was any difference on that one, but it'd be an interesting one to test and look at, which we could probably do now, if we're being honest, let's be frank. Live coding. This is where I'm going to show up how terrible I am. So you want to look at this then. And do you want me to do, I'll tell you what, let's test this for Another one. What I'm going to do. So I'm going to do this, and I'm going to caveat this very heavily that we're about to see roughly how long this query takes, but this is not indicative of Salesforce query performance before anyone starts messaging Chris or any of the Salesforce team saying, I looked at how long this query took. All right, deploy to org ran, well done. Okay, and all right, what do we think is going to be? Do we think it's going to be faster, slower? Do we think it's going to be faster?
I reckon it's going to be slower.
You think it's going to be slower? Okay, let's give it a go. There's a couple of questions we had whilst we were looking. Performance and scenario from Salesforce all crew. Ooh, cool. Do you spend any time using the declarative tools? The declarative tools also hit the governor limits as quickly as code. Yeah, as a developer, you should use the declarative tools, and that is everything from what's the word I'm looking for? Everything from formulas, roll-up summaries, all the way up to flow and process builder. Most companies have a hybrid footprint, as Rob has said. I don't know if Keir's saying that you would hit governor limits quicker there. Is that what you're suggesting, Keir?
I find that if you're doing anything at enterprise scale with declarative tools like Flow, you'll hit governor limits quicker than you will Apex for sure.
Yes. Yeah. No, I think that's
harder to find as well when you're debugging the damn things.
Yeah, I'd agree with that. Oh, do you know what I've just done? Oh, 1 minute. We can see it here. I've just made sure my assertion messages at the end were exactly the same. So if we include the query, it is 67 and inline max is 68 and SOQL 4 is 171. So it's quicker than our regular SOQL 4 loop. It's more in line with our regular iterator. What's interesting is that our query apparently took 24 milliseconds. So very quick. Now, again, let's take a step back because this is being recorded. Caveat this heavily. This is a really, really simplistic query on a really small amount of data in a developer environment that's doing a very noddy loop. It's not doing anything.
Your mileage may vary.
Yeah, your mileage may vary. Please do your own testing. Please purchase Salesforce based upon currently available functionality. Safe harbor.
Well, I think I've got enough footage just here to edit down nicely to send to Chris and go and say, look what Paul said. He said
he just spent 45 minutes slagging you off, Chris.
Yeah, he was like, here's a live coding demo that absolutely shows.
If you want, his email is chris. Any issues you've got, directly email.
Oh, Daniel Ballinger, I've got something for you to work on your first day.
Yeah, I'll see what I can do with this video, Paul, just to help you out there.
Yeah, cheers, mate.
Another question from Raja. Oh, here you go.
Yeah, can you share some tips on how to process blob data attachment with greater than 10 megabit size from external sources? So first of all, you're going to have to, so there's a limit of 12. Yeah, AWS is probably the best answer there. Or Salesforce have a small platform called Heroku that you could use to help do that sort of stuff. If it's under 12 megabytes, theoretically, you could process it in an asynchronous method, but I would suggest, this is not what Salesforce is built for. Process it externally. Heroku, AWS, Azure, GCP, choose your platform of choice. Obviously, Heroku for everyone on this call. Depending on what, this is another question around that though, Raja. Is it image data or is it blob data? Like when we say blob data, is it images or is it something else? Videos. Okay, there's have a look at AWS because they do have a lot of video processing products on there that can help you out. So you may even be able to get something done without messing around too much. Any other questions? What would be a good use case for session cache? Oh, sorry, I saw this one earlier on and missed it. Session cache is data that is only applicable for that user, okay? So as I mentioned earlier on, that situation I had where there was a particular piece of information for that user that needed to live as long as that user's session did, but didn't need to be seen by anyone else. So it could be, so asynchronous jumps, as I mentioned, there is a good example. Another one might be that you've got some private cached data that you need to make it quickly and readily available across the different transactions. Again, another reason to perhaps use cache data is it's data that you don't want to store in Salesforce, but you want to store across transactions. Transactions being interactions rather than necessarily long-lived Apex transactions. So there's going to be a few of the use cases in there. There you go. Narendra's got a great one there, maintaining subscriptions for a user. Hope that helps. Any others? Cool. Well, if anyone comes up with anything as they finish for the rest of the evening or tomorrow or whenever, as I say, I'm pretty easy to find on Twitter and LinkedIn and everything else. So if you did have any more, please feel free to ping them to me. Happy to help out. And thank you very much again for having me.